So recently, a very old paper by Dijkstra on the foolishness of natural language programming has been doing the rounds on Hacker News. A lot of tech influencers have picked up on this and made the argument that this can be applied to how we're doing AI assisted coding or vibe coding these days. And the thing is, I agree with pretty much all the arguments that Dijkstra is making about the benefits of a formal, rigorous notation for programming and math and all those things. But I still think AI assisted coding has a lot of value. So I wrote this blog post about it. I'll leave a link to it below. But I just wanted to quickly talk through it. So, what are the reasons Dijkstra gives for having a precise formal notation? Now, these reasons, most people would pretty much agree with all these reasons, especially if you're a mathematician or a computer scientist. So, first of all, formal language is really precise. It lets you express exactly what you mean. And if you look at history, the entire modern edifice of advanced abstract mathematics and physics and finance and computing, it all stands on very, very formal and rigorous math. And math took off only after it adopted formalism. Dijkstra is making the case that there was this entire period in history when math was still done in a verbal manner with natural language, and that held it back. And only when people like Descartes and Leibniz and others formalized math into very precise notation, very precise language, that's when math really took off. The other argument against using natural language is that it's very easy to make statements that are vague and that don't hold up to rigorous scrutiny, that just are nonsense if you really examine them. And this happens all the time when we talk to each other. But here's the most important argument that Dijkstra makes against natural language. He's questioning, even if we did allow programming in natural language, would that actually simplify the human's life? And this is the most important point in this paper by Dijkstra. And the argument goes like this. When you use any kind of interface for a human to communicate with a computer, there is some work that's happening on both sides. The most common example of this is when you write a program and there's a compiler that compiles and runs. The human does the work of actually thinking through the problem and expressing it in a syntactically correct program, which is a fair amount of work. And then the computer takes that syntactically correct program and compiles it and runs it on the machine. But the thing is, the work required is also dependent on the interface itself. Things like verifying whether this communication was successful, verifying whether there's any ambiguity or clarifying any ambiguity. And all these things have a cost. And Dijkstra is arguing that on the surface, if you were to allow programming with natural language, it sounds like it would really reduce the effort that the human would have to put in at the expense of spending a lot more compute. But because there is a reduction in precision, an increase in ambiguity, what will end up happening is that there will be a big increase in the human's burden to verify the correctness of this natural language program. So even though it might look on the surface like it really simplifies the programmer's life, it could actually be a net increase in the cognitive burden for the programmer. And that's the argument that many folks are using against AI assisted programming or vibe coding. Now, I agree with all of that. And if you look at, again, historically, how math and computing took off, you can thank in large part a rigorous formal notation for all those things. But Dijkstra's focus is on correctness. And that was a big focus, rightly so, in early computer science. when you were writing some of the fundamental algorithms and systems that all of computing depends on, you had to be really precise and rigorous to prove the correctness of those things. But the thing is, by now, all those things are pretty well settled. If you look at the very basic layers of today's computing stack, things like CPUs and the instruction sets, OS kernels, compilers, interpreters, all those things, they are fairly well understood. They've been built with a lot of rigor, a lot of testing, and they are really feats of modern engineering, and they're pretty stable and quote unquote as correct as you can make it. But this argument for always needing formality doesn't quite translate to the application layer, the kinds of apps that we're building today. So if you look at how modern software engineering happens in any large tech company or any business for that matter, there's no preconceived notion of correctness. The correctness, or in other words, the specification for the software, is almost like a discovery process. You have to build and test and get feedback and iterate, and that's how you build towards some sort of an ideal. If you think of most modern web apps, social media apps, uh, productivity apps, so on, or even if you look at internal enterprise apps that have a lot of business logic, yes, there is a notion of building software that meets the specification, but the specification itself is a very dynamic thing. It's not expressed in some kind of a formal language. The specification itself, a product requirements doc or a business requirements doc, is a natural language document. And that imprecise natural language document is then taken by technical folks like system architects or engineers and turned into software, which of course is executable and you can run it and see the results of it. But the main thing to note is that this entire process is an iterative one. You go back and forth between the specifiers and the builders, and that's how you inch closer and closer towards a system that you're satisfied with. And so most modern software engineering is about discovery and evolution rather than building against some kind of a static specification. So this whole activity isn't very amenable to formalism to start with. And because of that, this argument of natural language programming not working well, I don't think carries over to modern application level software building. Because you want to quickly build, quickly change, quickly iterate, all the affordances that vibe coding or AI assisted coding gives you really helps you accelerate that iteration. And folks like Clairvaux, Sahil Lavingia, I'll post links in the description, they've also been making a very similar point. And the way that shows up is that all these well-known roles found in most tech companies like product manager or engineer or UX designer, the lines between them are blurring. And no one knows what to call this new role, a person who can have a product idea, quickly prototype it with AI generated code, iterate on it, and not have to wait on a team of engineers to do all that. They're calling it a product engineer, but it's this new thing being created right as we speak. So I'll leave a link to this blog post. I just wanted to make this video to go with it. I agree with Dijkstra on the advantages of formality, but I don't think it applies directly to the kinds of software engineering we're doing today. And the kinds of software engineering we're doing today definitely benefit a lot from AI assistance. All right, thanks.